All right, so this section is called Systems of Linear Equations. So we're going to be looking at linear equations in two variables. That just means we're going to have both x and y in our equations. So what is a linear equation? Let's just remind ourselves. So the basic form of a linear equation is y equals mx plus b. So we have our two variables, y and x. These other two look like variables, but they're just standing in for some values that will occur in the equation. So m is equal to the slope, and b is equal to the y-intercept. So let's look at an example. So we have y equals 3x plus 2. So what this is telling me is that my slope is 3 and my y-intercept, that's where it crosses the y-axis, happens at 2. So if I were to graph this, this is going to be a straight line on a graph. That's why it's called a linear equation. Let's draw a quick sketch of it. So I know it's crossing the y-axis at positive 2 because it has plus 2 at the end. That's my y-intercept. And then I know that the slope is 3. So remember on a graph, our slope is rise over run. Since we just have a 3, we can think of it as 3 over 1. So we're going to go up 3 and over 1 from our point that crosses the y-intercept. So up 3 and over 1. Up 3 over 1. We can also go down 3 and over 1. So this is going to be the line graph. Whoops. Hopefully you go through the points you drew. So that's going to create that straight line. So what we're going to do now is we're going to look at two linear equations. We're going to graph them together. Well, we're actually not going to do much graphing, but I want to look at what it would look like graphically first. So it says when we take a system of two linear equations, we're looking for when the same x and y make both equations true. So if we look at more than one equation, we're going to have two straight lines, right? And we want to know where those two straight lines have the same x and the same y that make them both true. In other words, where they are kind of equal to each other. And so let's look at what can happen. Okay, example 1 here, we can have two straight lines that intersect in one point. So if we have two straight lines that intersect in one point, which is often the case, that point where they intersect, that's where they have this line and this line have the same x and the same y values, right there, right on that point. So if that is the case, then there would be one, and I don't know why I can't write here. Oh, it's just my color is bad. That scenario would have one solution, right? It would only have one solution because they're only meeting at the same x and the same y in one point, okay? So the other things that can happen, there's two more things that could happen. We can have two lines that are parallel to each other. If the lines are parallel to each other, they're never going to have the same x and the same y for both equations, right? So, because they're never going to touch or cross if they're parallel. So if this is the case, then we say there are no solutions. Okay, so you'll have that case sometimes where they never cross or touch each other. They're not going to have the same x and y that make both of them true. So they would have no solution. The third thing that could happen, and it looks like there's just one line here, but what's really going on is we have two lines, but they're both the same line. So one of them lays right on top of the other line. And I'm going to actually do a quick sketch on top of this. So, well, let's do a better color here. So if I have two lines, but when you graph them, they're actually both the same line, okay? That looks terrible, but one is right on top of the other. They line up perfectly, then you're going to have infinitely many solutions, okay? So this is what's happening graphically. This is what is happening graphically, but what we're actually going to be doing is we're going to be looking at it algebraically. But if we have one solution, we're just going to be finding that x and y value where they intersect, where they're equal to each other. So this will be where you get x equals a number, and it will make sense, and then you can plug it in, and you'll find that both x and y equal numbers. If there's no solution, you're going to get something that looks weird. So maybe like 3 equals -7 or something. When you're trying to solve for x and y, you're going to get something that says it's equal, but they're not equal. And if they're not equal, that's when you're going to have no solutions. If you're solving along and you get 0 equals 0, this is when you're going to have infinite solutions, okay? So let's go ahead and try some examples so that you'll know what in the world I'm talking about. Okay, I have 2 linear equations here. I'm going to be looking at them together. This means I want the same x and the same y to make both of these equations true, okay? So I'm assuming that y equals y in both equations and x equals x in both equations. So what I want to do here, I'm solving by substitution. So what I'm really doing is I need to solve for one of the variables. These are already solved for y, so I'll just go ahead and use that. If I know y equals -x minus 3, and I also know that y equals -8x plus 4, then I know that -8x plus 4 must equal -x minus 3, right? If they both equal y, that means they both have to equal the same thing. So I can substitute this y in this equation for this equation. So I can set this up as -x minus 3 equals -8x plus 4. So now I've made an equation that just has one variable in it. If I have an equation with one variable in it, I can solve for the variable, right? I can find out what that variable should equal. So that's what I'm going to do. I'm going to get all the x's on one side together. So I'm going to add 8x to both sides of the equation, right, on both sides of the equal sign. So 8x minus 1x is 7x, and I still have that minus 3. That's going to go to 0, so this is going to equal 4. Now I'm going to add 3 to both sides to get rid of this minus 3. I'm trying to get everything away from x, right? So 7x equals 7, and then divide by 7. So I know here that x equals 1. But remember, this is going to be 2 lines that intersect, right? I need to know the y value where they intersect also. So I need to solve for x, but I also need to solve for y. So if I go ahead and put x equals 1 back into either one of these equations, doesn't matter which one, you'll get the same answer either way. Then you'll know what y is. So -x, and this, if I plug 1 in there, would be -1 minus 3. So y equals -4. So I know these two graphs are going to intersect at the point 1, 4. Right, that's my x value, 1, -4. That's my x value, and that's my y value. Okay, I just wrote it as an ordered pair. That's the point where they're going to intersect. Okay, as long as I have x equals and y equals, that's fine. You can write it in an ordered pair or like that, it's fine. Okay, let's try another one. All right, again, these are already solved for y, so I can just take this equation and replace that y with that equation. So 1/2 x minus 1 equals -1/2 x plus 3. Okay, I'm going to add 1/2 x to both sides in order to get that to go to 0. So 1/2 x plus 1/2 x is 1x. So x minus 1 left over here. That goes to 0. I'm left with 3. And then just add 1 to both sides. So x equals 4. Once I know what x is, I can take x and plug it back into either equation. Again, it doesn't matter which one, just plug it into one of them. Y equals 1/2 times 4 minus 1. 1/2 times 4 is the same as 4 divided by 2. So that would be y equals 2 minus 1. So y equals 1. Okay, so again, you need to find both the x and the y value. You can write them as x equals 4, y equals 1, or you can write it as an ordered pair. Either one is perfectly acceptable. Okay, let's get the next slide here. All right, so this one, y is equal to 5x plus 3. I already have y all by itself on one side, so I can take 5x plus 3 and replace this y with it. I'm just going to plug it right in where that is, because if y equals 5x plus 3, then I can take and replace that y with 5x plus 3. So 5x plus 3 minus 5x equals -1. So again, because y equals this stuff, I can put this stuff in where y is. So that's all I did is took the y out and put in 5x plus 3 where it was, and then wrote the rest of the equation. Minus 5x equals -1. Now I'm going to go ahead and simplify this. So these are both on the same side, so I'm going to combine them. They're like terms. 5x minus 5x, though, that's 0. So that's actually just going to go away. And I'm left with 3 equals negative 1. Right? That doesn't make sense, right? 3 does not equal negative 1. And my x has disappeared. So I know this has no solution, right? Those two lines are going to never touch or cross. All right, so notice our instructions changed here. The other said solve by substitution. This one says solve by elimination. So we are going to, in this case, try to eliminate one of our variables by taking our equations and adding them together. So notice here I have a positive 2x in the top equation, and in the bottom one I have a minus 2x. I can actually just go ahead and add this whole equation to this whole equation, right? I have to keep like terms together and add like terms. But if I take 2x minus 2x, that becomes a 0, right? That makes my x's go away. Then I have 5y minus 20y would give me negative 15y. And then 5 minus 20 is negative 15. So negative 15y equals negative 15. Divide both sides by negative 15. And y is equal to positive 1. Now again, to eliminate, to solve by elimination, I'm going to add the two equations together. I want either the x's or the y's to cancel each other out. One of them, at least one of the variables, to go to 0. So in this case, it worked out because I had a positive 2x and a minus 2x, and those, when you add them together, automatically go to 0. But sometimes we might have to do a little bit of math first to get that to work out, where we have equal but opposite coefficients, right? They're equal in value, but one of them is positive and one's negative, so they're opposite. Now that I know what y is, I know y equals 1. I can use that to find what x is. And again, I can use the top equation or the bottom equation. Doesn't matter to find x. So I'm going to use the top one here because it's smaller numbers. So 2x plus 5 times y, and I know y is 1, equals 5. So 2x plus 5 equals 5. Subtract 5 from both sides of the equal sign, and 2x equals 0. So if I divide both sides by 2, 0 divided by 2 is 0. So the point where these two meet is going to be at 0, 1. X equals 0, y equals 1. Okay, let's try another one by elimination. So on this one, notice x and x, one of them's a 3 and one's a 2. Up here is 6 and 2. The value's not matching. These ones are opposite sign. But we need to get them so that they're equal and opposite. So equal value and opposite. So I can do a couple of things to do that. I can either do it for 2's or 3's. For x's or y's. I think since I know that 2 is a multiple of, or that 6 is a multiple of 2, I'm going to go ahead and try, and they're already opposite signs, I'm going to go ahead and get these two to both be 6. In order to get a 2 to equal a 6, I'm going to have to multiply it by 3, right? If I multiply one term in an equation by 3, that's going to throw everything off and make this equation untrue. So in order to make it still true, I'm going to have to multiply each term in the equation by 3. So 2 times 3 is 6, so this would be 6x. Negative 2 times 2 gives me negative 6y. And negative 2 times negative, no, not negative 2, 3 times 24. 3 times negative 24 is 72, negative 72. Okay, so I'm crossing this one out, and now I have this new equation. I multiplied each term by 3 so that it would still be equal all the way across, but now I can take this equation and this equation and I can add them together, and that 6y and 6y will cancel one another out. So I'll have 3x plus 6x, which is 9x, right? I'm just adding this whole thing together. Well, it's more like times, but I'm adding these two equations together. 3x plus 6x is 9x. 6y minus 6y is 0. Those go away. 27 minus 72 would be negative 45. Okay, and then to get x by itself, we need to get rid of times 9. We'll divide both sides by 9. Negative 45 divided by 9 is 5. So x equals negative 5. In order to find y, I need to plug negative 5 back into one of the equations. I can use this one, or this one, or this one. It does not matter which one I use. Just plug x in and you should get y back out. You'll get the same answer no matter which equation you use. I always like to look for the one with the smallest numbers. I'm going to plug it into this one, the one I crossed out. So that would be 2 times negative 5 minus 2y equals minus 24. This gives me negative 10 minus 2y equals negative 24. If I add the 10 to both sides, negative 2y equals negative 14. Divide by negative 2, and y equals negative 7. So x equals negative 5, y equals negative 7. That point where they're going to intersect on the graph is negative 5, negative 7. All right, let's try one more. I think we have one more. So we have 9x plus 9y equals negative 9, and negative 3x minus 3y equals 3. So I can see that these are multiples of 3 of each other. So in order to get equal values of opposite signs, I could either divide the top one by 3 or multiply the bottom one by 3. I'm going to go ahead and multiply this one by 3, which would give me negative 9x, negative 9y, and 9. So negative 3 times 3 is negative 9, negative 3 times 3 is negative 9, 3 times 3 is 9. Now I'm ignoring that middle one, I'm just looking at these two. 9 minus 9x is 0. Where'd my marker go? 9y minus 9y is 0, and negative 9 plus 9 is 0. So here we got 0 equals 0. So remember earlier I said if we get this 0 equals 0, this means that there are infinitely many solutions. Okay, this means that the lines are right on top of one another. Okay, so there's infinite solutions. They both make up the same line. Okay, we're going to look at a couple of word problems. We're going to set up these word problems using systems of linear equations, and we're going to go ahead and solve them. So it says Alaya and Ming are selling cheesecakes for a school fundraiser. Gosh, I can't speak. Fundraiser. Customers can buy pecan cheesecakes and strawberry cheesecakes. Alaya sold 4 pecan cheesecakes and 13 strawberry cheesecakes for a total of $279. Ming sold 2 pecan cheesecakes and 5 strawberry cheesecakes for a total of $111. Find the cost each of one. Find the cost each of one. Find the cost of 1 pecan cheesecake and 1 strawberry cheesecake. I'm pretty sure that's what it's supposed to say. So we're going to say that X is the cost of 1 pecan cheesecake and Y is the cost of a strawberry cheesecake. Okay, so if Alaya sold 4 pecan cheesecakes, he would have 4 times the cost of a pecan cheesecake, which would be 4 times X, and adding 13 strawberry cheesecakes, so 13 times the cost of a strawberry cheesecake, would have equaled $279, right? If I sold 4 pecan cheesecakes, I would need to take the cost of a pecan cheesecake and multiply it by 4, and then I would need to add that to the number of strawberry cheesecakes I sold times the cost of a strawberry cheesecake, right? That would equal the total number. Now Ming sold 2 pecan cheesecakes, so 2 times X, and 5 strawberry, so 2X plus 5Y, and that was a total of $111. So now we can use this little system of equations in order to find out the cost of 1 cheesecake, 1 pecan and 1 strawberry cheesecake. Now, I could use substitution here or elimination. Either one would work. If I wanted to use substitution, I would have to first rearrange one of these equations so that X or Y was all alone on one side of the equation. Okay, I'm actually going to use elimination here because I see that 4 and 2, 4 is a multiple of 2. So I'm just going to go ahead and multiply the bottom equation by -2, right? If I multiply everything in the bottom equation by -2, I'm going to have equal opposite terms here. So I'm going to write it above here. So -2 times 2x is -4x. -2 times 5y is -10y. And -2 times 111 would be 222 negative. Okay, so I'm ignoring this one now, and I'm just looking at these two. I'm going to add them together. So -4x and 4x is going away. That's what we wanted to happen, right? We wanted to eliminate one of our variables. -10y plus 13y would give me 3y. And -222 plus 279 would be 57. Is that right? 9 minus 2 is 7. 7 minus 2 is 5. Yeah, so 57. So if I divide both sides by 3, okay, 57 divided by 3 is 19. Okay, so we know this is in dollars. So y was the cost of strawberry cheesecake. So that is $19. It costs $19 to get a strawberry cheesecake. For the cost of a pecan cheesecake, we're going to have to go ahead and plug our $19 back into one of our equations. Doesn't matter which one. I'm going to use this bottom one that I crossed out. So 2x plus 5 times 19 equals 111. 5 times 19 is equal to 95. So this would be 2x plus 95 equals 111. Subtract the 95 from both sides. 2x equals 16. Divide both sides by 2. And the cost of a pecan cheesecake was $8. No wonder they sold more of them. They were a lot cheaper. All right, one more word problem. A boat traveled 112 miles each way, downstream and back. So the distance doesn't change, right? They're going back, downstream and back. Each way was 112 miles. The trip downstream took 7 hours, but the trip back upstream took 14 hours. Find the speed of the boat in still water and the speed of the current. Okay, so if x is equal to the speed of the boat in still water, and y is equal to the speed of the current, okay, then we know that if we take our 7, it took 7 hours to get downstream. So when you're going downstream, the current is aiding you, right? So if I take 7 and multiply it by the speed of the boat in still water, because that's the hours that it took, and this is the miles per hour, right? And then I took the speed of the boat in still water and multiplied it by the speed of the current, okay? Because it took 7 hours to go. Well, a better way to look at that would be it took 7 hours and we had the speed of the still speed of the boat and we add the current, right? Because if you have a current, you're going to have the speed of your boat plus the current times the number of hours it took to get there. That's going to give you the number of miles that you went. And then on the way back, it took 14 hours. The still boat was fighting against the current, right? So the speed of the boat minus the current equals the number of miles. Okay, so if I go ahead and distribute these in, I'm going to have 7x plus 7y equals 112. And then the other equation would be 14x minus 14y equals 112. And I can now use this to go ahead and solve. I'm going to use elimination again, although you could use substitution if you wanted to solve one of these equations for x or y first, then you could plug that equation in for the x or y in the other. But since these are already a multiple of each other, these ones are already opposite signs, I'm just going to go ahead and multiply everything here by 2. So 7x times 2 would give me 14x. 7y times 2 gives me 14y. And 112 times 2 gives me 224. So now I can take these two bottom equations and I'm going to add them together. 14x plus 14x is going to give me 28x. 14y, negative 14y and 14y is going to 0, so that gets rid of that for us. And then 112 and 224 would give me 336. If I divide both sides by 28, I'm going to grab my calculator really quickly. 336 divided by 28 is equal to 12. So 12 miles per hour is the speed of the boat in still water. The speed of the current we can now find by plugging x back into either one of the equations, or actually all three of these equations would work. I'm going to plug it in the top one again because I like the smaller numbers. So 7 times 12 plus 7y equals 112. 7 times 12 is equal to 84. So 84 plus 7y equals 112. Subtract 84 from both sides, and I've got 7y equals 28. And divide both of those by 7, and y equals 4. So the speed of the current is 4 miles per hour. Okay, so you can use these systems of equations to solve these type of problems, which you'll have if you look on your homework. So good luck, and we will see you next time.